Hello everyone and welcome to Handmade Hero Show. We code a complete game live on stream. We are going to, well, honestly, we're going to do what we were going to do last weekend, but we ended up just having a giant discussion about caches because that was some questions that people had. And so we kind of went through all of the stuff that you kind of want to have as background information on them. And that took up the whole 2 hours. So today we're actually going to get back to what we were trying to do, which is to start to extend our entity system to have some larger storage in it. And the idea behind what we did just prior was to set us up so that we could really take probably, I mean, not literally infinite, but we could start to use basically as much storage as we want in our entities because we don't have to keep it permanently. So it only, we can have our entities when they're actually being simulated and they're in the local region that where the player is currently playing, those can be quite large and quite sophisticated because they then get packed down later into smaller, sort of more concise versions for long-term storage. So that's the two-tier structure that we ended up creating and already is working now. So we've got that done, but we haven't actually added anything to it to actually use this sort of model for any productive purposes. So what we want to do is start down that road. So if we open up the game here in Remedy, which is the debugger written by George Manhorn, he's X13 pixels. Looks like we're still in debug build. I guess we didn't build a release mode for some reason, not sure why. Let me go ahead and switch into debug build there so we can hop around. One interesting thing we may be able to do too is if we do improved lighting, which is kind of on the schedule here for stuff we want to do with the larger energy store. Improved lighting would also get rid of the fact that our debug build is slow because all of our time in our game is spent in the lighting, and we can do better. Right, we can make a better lighting system. So that's a sort of an interesting side effect that we can do there. So anyway, what we wanted to start doing is to utilize that energy system as twofold. One is you can see the lighting is still just sort of our little test lighting volume. You can actually see the edges there as we move around. It only contains a small region of the world at the moment. If we actually zoom out, you can see that's the region that gets lit. And what we want to do is be able to light a much larger region than that as we go forward and have it be much faster. So we want like faster, simpler, better lighting, right? We just want a general improvement of that system, which is always hard. Lighting is one of the most difficult things that you encounter in games, certainly. Largely because doing it correctly is impossible, so you're always dealing with trying to do some approximations that give you good results but have reasonable speed, right? Okay, so we want to do that, and the other thing that we want to do is indoors, right? Like this is roughly what we wanted it to look like in terms of what the general layout is. We've got these sort of little tiles. I wanted them to sort of be like rough and uneven and stuff, and have a texture on the top that's like whatever wood grain or stone or something. And as you can see here, like that's pretty much done. Like that is fine. Like that looks the way I wanted it to look. I don't really have any problem with that. So that's all good, but what's not so good is if we go outside, this is not what I wanted, this is not what I want the outdoor regions to look like. So we tried spamming some trees in there, and that's all fine. So I think putting down trees when we want to write our final tree distribution, you can see you can put trees, we got snowy trees, we got non-snowy trees, whatever, stumps. That all seems to be fine. What isn't fine is just I wanted to be able to sort of spam ground cover around on these sort of small, like I guess not sure how to describe it really, but just I want to go through on these grass tiles and just put a bunch of little like flowery like grasses coming up and things like that, right? And so what we'd like to do is we'd like to just have some way of spamming that grass out when something comes into the active set. So, this region here, just spam it out there and produce like whatever we're going to use for the grass, right? So we want something like that, but then when the thing goes out of the active set, meaning, you know, I hop up here, right? And then stuff, well, I guess I have to actually change rooms first, but let's move out here and you can see it happen more specifically. So as I walk upward through this hallway, these things will come out of the active set, right? You see they're gone now, right? They're just disappearing. And so as things come out of the active set like that, what we want to be able to do is we want to be able to throw away all of that data about where all the grass is, because that's just going to be a ton of extra information there that we don't really need to be storing. Now, in order to do this stuff and keep tabs on it, we also have a new friend with us. This is our memory arena. And as you can see from here, it basically keeps track of everything that we have allocated and tells us who's using what and where. I'm not sure why this is not broken up into tinier pieces currently, because I thought the last time we checked into here, this was sort of partitioned into little chunks, but I guess that's not happening. Oh, right, because we haven't actually looked at this since we did our major changes. This is now just a let's go back to the sizes. So this is now inside our game storage. We now just have a giant cache, effectively, of entities that are expanded, and they just go in that giant pool. So that is just one big allocation that stores the entire game active set at any given time. And then we only get little world chunks when things have to get packed back in. And I would wager, I guess I don't actually know, but I would wager that right now we're actually not even spilling, probably. So the whole world just fits in the unexpanded version, and we don't get that. So, you know, that's kind of interesting. If we went back to the world mode here, sorry, not the world mode, the world, and we take a look, I just had forgotten that would actually happen, but that is what would happen. You don't need to pack anything if things stay in the active set. I believe what we would see here is if we were to change this number, revise it down, so let's say it was more like that, right? Then I think we would start to see more in terms of packing, right? If I now take a look at that memory set, there you go. Okay, wow, that's cool, right? This is why I really like these visualizations, right? Even when you're the one who wrote the program, you oftentimes won't remember, or won't think through how things will change. And when you can see them operating, you can tell. So here's the cache. This is expanded entities that are capable of running directly and simulating, right? And these are all the compressed entity chunks, right? Now, right now, we don't actually do any compression. That routine just stubbed out and will likely remain stubbed out for a while because we don't care about actually doing the compression for a while, and during development it's easier not to bother. But as we start to tighten down the memory requirements for the game, we can get a lot of win there, right? And so you can kind of see that process setting itself up nicely. So that's pretty cool. You can actually watch that cache getting used, and at the size that we set it to, which was 4 times the maximum sim region count, at that point you've really got enough that the whole game just runs out of it at the moment, because we just don't create large enough worlds. In the future, we'll be creating much larger worlds. They'll be and not just spatially, but just there's more stuff in it, right? Because right now it's mostly empty. We haven't put the game design stuff in there that will create lots of new entities and stuff like that. And also, I think there's only 1 or 2 levels of the dungeon. I don't know, 3 levels of dungeon. I don't know how many levels of dungeon it went down, but it's not much. So as we add more, we should be actually utilizing more than 4 times the max sim region entity count anyway, but that's sort of a separate issue, right? Okay. So I think that's roughly what we're looking at here. And what I want to do now, like I said, is look at maybe doing some of that ground cover stuff, so that as entities come into the set, I'll sort of spam ground cover out onto grassy areas, and things that want to have grass will have them, right? All right. So if we go back into our entity set, let's just take a look at the entity structure itself here. If we're in the entity structure and we want to start adding this, here's like the stuff that we have for lighting storage, and here's the stuff that we have for ground cover. These two things are both elements that don't really need to be there, and you can see there was a to-do here for the lighting. Elements that don't really need to be there when there isn't some when the entity is sort of packed away. It's not in the active set, it's not being used. And there's more down here in addition to that could be as well. A lot of this animation sort of stuff, right? Like all this, you know, these angle swipes and base and all that stuff. All of the things that are animation related also don't need to be there. So a lot of this stuff can sort of be packed up into like a more concise format, and you know, we can just truncate the entity as we go. So what I'd like to do is start by actually doing something like that, where we kind of have some knowledge about how it might get truncated. I'm going to do the simplest possible thing first. And this is just a really, really basic idea, but I'm going to start with it, which is here, where I sort of say, okay, we're going to have some extra data with our entities. I'm gonna do something like say, well, maybe, and there's two ways I can go with this. I'll just tell you what they both are. Way number one would be that we keep the entity struct this size, and we just truncate it when we pack it. So when the entity gets packed down to a smaller size, we just don't pack down the ending bit, right? We just leave it off. You know what I'm saying? So that's one way to do it. Another way to do it is these could actually now be things that are more complicated. So for example, we could have secondary rings of data for things like ground cover that we just allocate to an entity when the entity comes into service and then remove from the entity when it goes out of service. And I think that's actually more like what we're going to move towards as we go, because things like ground cover, at least, maybe not lighting point state, but maybe, but ground cover at least may reside entirely on the GPU, right? Because the GPU could know how the ground cover is arranged, and there could just be like a vertex buffer that's stored that says, here's where the ground cover goes. And so we wouldn't really need to store the ground cover data on the CPU side. It could always just reside on the GPU side. And so then the entity pack unpack stage, still very important, just instead of being there for modifying CPU memory, it'll be there for modifying GPU memory, right? And so I think that's where we're going to go with it eventually. But I don't want to run before we can crawl here. So what I'm going to do for starters is I'm just going to define a boundary that says at this point in the code, everything after it can get discarded, right? And so this is kind of just like a temporary way we're going to deal with this for the moment. And it's a really easy way for us to just do our packing and unpacking. So what this means is, here's our lighting and our cover information. We're saying that all of our entities, and, you know, I may go back here temporarily and sort of do this again as well, just so we can watch it happen. All of our entities are going to have all of this stuff in them when they're in the cache right now. So when we run and we look at sort of this part, right, and we look at how this is getting distributed, you can see that we've got all the packed entities here, all the cache entities here. These entities and these entities currently have all that data. So what I'm going to do now is just remove that data just from here. So when an entity gets packed, so out of the active set, this storage will no longer contain that extra space, right? So how are we going to do that? Well, inside the world struct, we know exactly what's going on. When we call unsure region is unpacked, we know that those pieces of information are going to come into being, right? And so when we go, well, actually, I think this does both of them, right? But anyway, point being, when we come in here and we call acquire unpacked entity slot, that acquire unpacked entity slot call is the thing that preps that region. So if we look at what that does, you can see here that it just kind of grabs it and then gives it back. And so we want to probably, at this point, oops, that's not what I wanted, acquire, unpack, and stop. We want, at this point, to do something a little bit more than just taking whatever the source data is and slamming it back in there. Because now what we're going to do is we're going to start using a smaller size for the actual packing, right? All right. So how are we going to do that? Well, first of all, we need to start maintaining an actual pointer here. So we're going to use sort of a read pointer, and I want to do, I want this to start looking a little bit more like a streaming construction, because like I said, in the future, I think I'm going to want to do some like more advanced compression-y sorts of stuff with it. And so I want it to start looking a little bit more like our PNG sort of stuff, right? And so if we look, I think, I mean, I don't know, but I think we may just be able to go ahead and use our stream here. Because if you remember how our stream worked, you could just make these calls, like consume this much from the stream. And, you know, this is what I want you to give me for data, right? And so if we have something like that that we use on top of the stream, that may be the easiest way for us to really work this stuff out. Now, there's a couple things that aren't probably ideal about it. Namely, it can't read across boundaries. So this stream was made to just only work on a single boundary. You can see that happening here where you've got the file underflowed thing being true. Because I think this refill if necessary, right? This thing is only getting called once. So what happens is while the stream is reading, it can read out of multiple chunks, but it has to read individual things out of it in as a single block, right? Now, I don't really need to replace that now because in fact, that limitation may be fine just in general, but it's worth noting that it is there, right? And so it's something that we just want to be like aware of, if that makes sense. But otherwise, you know, I think this is something we probably could use. If you look at how this is set up, we've got this stream chunk here with the buffer contents and that stuff. I could, however, also just make a custom one just for the world. And the reason why we might want to do that is because, again, these entity blocks we already have are kind of doing something relatively specific there. And so on and so forth. So I don't know. Kind of hard for me to say what I really want to do there. I think what I may do is just say, yeah, let's just kind of clone just that one consumption sort of operation maybe, and I'll implement it specially here because I think the stream is just not quite compatible enough. I don't want to shoehorn it in there, and this is probably going to be a relatively important part of our program. So I'm gonna keep it more straightforward than that. So what I'm going to do here is just pretend I have the thing I need, and I'm going to write the two sides at the same time just so I can make things nice. Here, where we have this code right here, this is where we pack an entity. So this part of the code right here packs an entity into a waiting stream. So you can see it here doing the adjustments for the entity location. Then you can see this getting space for the entity there that it's going to try to write in, and then there it is writing it. And so what I want to do now is kind of figure out, yeah, I want to kind of say, how do I want that to work on this side and this side where we're not reading out an entirety of an entity? Well, the basics here would be just say, all right, how much do I actually want? So if I take a look and I say like total entity size, or maybe packed entity size, right? What's that going to be? Well, I know that this is how big the entire entity is. But I also know that inside my entity struct, I have, right, like this discard everything after, I have a point that I don't want to store past, right? So I want to look and see where is the, you know, where is that actually going, right? How far in is it? So a long time ago, we wrote this macro, which is just kind of an easy way of saying how far is this member from the beginning of the struct. It says, assume we're starting at a pointer value of 0. So the struct starts at 0 memory, the base of memory. How far would we have to go to get to the member, right? It's just using the address of operator for that. And so what I can do is I can say, all right, if I know the offset of that thing in memory, right? Instead of saying size of entity, what I could just do is say, well, how far would I have to get if I went all the way to this discard everything after? That's the size of all the things before it, right? So it gives me this sort of easy way of figuring out how much I need to save, and everything else after it would get discarded. So if this was the packed entity size here, then I could just change this code to use that size. So I could say, well, let's just instead use, packed entity size. So we'll use that much chunk space. When this comes back, I'm not going to do entity star. I'm just going to call this a void star. And then I'm just going to do a regular copy of the packed entity size. And I'm going to say, go from the entity to this destination, right? Now, this part isn't going to work, this clearing part here, because we've now sort of destroyed the ability to access entity. That's okay. This is just saying don't actually store these, for all intents and purposes. And so what I want to do is just let's now use our packing for that. We have DDP and we have DDT Bob, and it's saying don't pack it. Well, all right, let's just not pack it. So this stuff will now just get discarded, and that means we don't have to do anything with it here, right? So this is what we're doing. That's our code. I'm going to pull this out for now because it happens to be shared at this, at this stage. And so what I want to do is in here where we do this operation, I want to make a symmetric version on the side that actually does the unpack, right? So where we do this. So when we acquire an unpacked entity slot, I now want to make sure I can copy the rest of the stuff into it. And what you'll see here is that this code is actually kind of wrong, and I guess I should update the other piece of code as well first. So you can see here when I do my use chunk space, this is only going to advance by however much space Now that I'm looking at that, does our use chunk space call? Who updates how many entities there are? Okay. So what you can see here is we have the entity count getting updated as well. And again, that's something that I pretty much don't want to do anymore. The reason for that is if our entities start becoming flexibly sized, which I would like to get to as well, because eventually I think that's probably the right way to go. We don't really want, we don't want to be doing stuff with a unit block sized entity, right? We want to be flexibly reading the data. So I think what we want to do here is just treat this, again, a little bit more like a streaming thing and say this is not there anymore, right? And we've got this entity data. We're just going to use this entity data size to say how much of it's filled, and that's what we're actually going to use. So this entity data here with this world block size minus 16, instead of 16, we're going to trim off 4 bytes from that, right? And we're going to say, okay, it's just an up to 8 byte pointer, and then a 4 byte size. And that's all that's going to be in here. So once we trim that off, we can get down to just 12 there. Now, when we look at entity data and we say, do we really need entity data size there to be 32, a 32-bit integer? What you can hopefully gain from this is like, well, hey, oops, that's not right. Here, this world block size at a maximum is only 16 bits. And we know that we've already taken up some of it. So actually, this can just be a 16-bit integer if we want to. And then we can save an extra 2, right? So now we've got world block size minus 10 worth of storage, which is basically just room for the next pointer and a little thing that says how far we should go to the end, right? Now, even that's probably not actually 100% necessary. We could do something even squinkier if we really wanted to. But for now, I'm going to stick with that, and I'm going to get rid of the entity count stuff altogether, right? So here is the block entity count. I'm going to get rid of that. And I'm going to recompile now and just get rid of it everywhere it is. And then we're going to go from there. Okay. Yep, so we don't want that. And this, when we do the plus equals size here, this size value is a 32-bit value. That's okay. When we do this has room for check, that will take care of it. So it should be a safe truncate to U16 here, where we can just say we're only going to use 16 bits of that data. All right. So as you can see, the packing side is much simpler. It doesn't really need to know how many entities there are because it's the one creating all of that used chunk space in the first place. It just streams it out till it's done. And that will track how much total space is used. When we get back here and we go through these blocks, as we are unpacking our entities, the problem that we're going to have here is, again, without this, we don't know when we're done. But since we have the entity data size field, that's going to tell us how much we have left. So really in here, we can change the nature of this to a slightly different way of looking at the data, right? What instead we could do is have a U16 here that's like we'll start at 0. I guess I could do it this way, right? We'll go until we're under the entity data, like when we get to the entity data size, we have to stop, right? And so then as we read in here, we can just advance that pointer. Once that pointer has read all the data in the block, we know we're done with the block, right? Now this will get more complicated, and we'll want to pull this out to an actual little struct probably that like streams things in for us as we go. But at the moment, since we're not running out entities in pieces, we can still keep this structure of doing one entity at a time inside the inner loop, with this actually being a loop around it. That's actually totally fine. But once we get to the part where an entity might be stored across 2 blocks, which there's no reason not to do, it's pretty easy for us to extend to that, then this has to get lofted up into a thing that just does the check every time, right? So it would actually be in here where we would say, you know, make sure we haven't reached the end of the... It would be a for loop that goes and gets a new block if it can. If it can't, we're done. If it... or sorry, I should say, it checks to see if we've run out of bits in this block, and when we have, gets another block. If it can't, then we're actually done, right? So it's just it won't be as complicated it won't be as straightforward as for loop. It'll be something that looks more like that with the actual code inside and a break statement, right? But for right now, we can stay with a simpler version because we know we're only packing whole entities at a time still, so it's a simpler process that we're doing. So we don't really want to do any of this anymore, right? We do want the dest to do the acquire unpacked entity slot, but here this is going to be more of the same, where we take the packed entity size that we expect. We're going to take the destination here and say we're going to copy into that. So then we just need our source. So we need the entity data for the block plus where we're actually at in the block. That's where we're going to copy from. And then when, of course, it has to do the unpacking of the position as well. When we're actually done with that read, we also then want to advance our at pointer to be that packed entity size. So again, we're just consuming that much out of the packed stream, right? So now, in theory, barring problems that I may have introduced, hopefully that is correct. Meaning, hopefully we've got the right logic in there now, and once we just debug that, we will still have our game running exactly as it was, only now when we store our entities for long-term storage, it will strip off that large section at the end of it. And so if we take a look inside the arenas now, you can actually see how much there's drastically less storage being spent on the entities that are in long-term storage, right? It was like 2-3 times the size of that before, right? And so now when I'm hopping around, in theory, as things get packed and unpacked in through that set, we shouldn't see any bugs, and we don't, so I guess maybe I did that at least roughly right. We haven't stressed that system or tested it much, so it's a little premature to say anything like that. But certainly it's not obviously busted, because as these new entities are coming in, they're working just fine. There's our little saucy gentleman hopping around, and the lighting is all just fine. Now let's go back to an area that was packed up. Again, we shouldn't expect to see anything different here because since our world generation code uses the world system as it is in the first place, if unpacking was broken, we would have expected to be broken the entire time, not just when we pack and unpack and repack and so on. But, I don't see any particular issues here. We don't really know how hard we've tested it, like I said, but that seems fine. All right. So that's, again, the first stage, and that just gets us in the habit of having this packing work. Now, as you can see, when we have ensure region is unpacked here, what I want to do is when we actually go to do an unpack, which is here, when we call register entity, we kind of want register entity now to potentially do more stuff, right? Or rather, we want, I guess we shouldn't say do more stuff. We actually just probably want a separate call because register entity needs to be done when we just use entities that are already in the set as well. So here what I'd like to do is, fill entity or something. Something like this. So what I want to do here is say, hey, we've got an entity. It was packed to long-term storage. Now we have unpacked it. And it needs to recreate like any stuff that gets generally discarded. That's got to start coming back in now, right? And so inside, and in fact, I guess this could be just in the entity code itself. I really don't know exactly where I want it, to be completely honest with you. But what I'm going to do for now is just say, all right, let's just say there's going to be this call. I don't know where it's going to live. We can get to all that later. But for now, what I want to do is have this little entity dest situation going on in here. And all I really want to do now is just have some way of creating that ground cover every time one of these entities comes into existence. And so, creating the ground cover is going to be pretty simple, at least at first. I actually have a kind of a... So if you go out here and look on the interwebs on my blog, for example, I did a bunch of stuff with grass generation and ground cover for The Witness, which is, if you've never heard of it, it's a game by Jonathan Blow that does like it's a complete 3D world, like walk around kind of like first person-y sort of game. And so on the ground there's lots of grasses and flowers and things like this, and there was a planting system that their level editor had in it, and so I did the replacement for that. It was very slow and had a bunch of problems, so I did the replacement version. And while I was doing that, there were a couple things that I looked into. This particular one here was sort of a separate thing I figured out after the fact. Doesn't actually appear in The Witness. So this particular pattern doesn't appear in The Witness. But this whole series, you can see actually, here we go. Starting at visually pleasing distributions. This whole series kind of talks about the subtle aspects of ground planting and how you want to do them and that sort of stuff. So yeah, take a look at that if you're interested in. I talk about like blue noise and stuff like that, and things we'll cover here on here a little bit probably too. Anyway, you can spend a lot of time on grass packing, on grass distribution stuff. I don't know to what extent I really want to do that much with that on stream, but point being, we'll do something probably better than white noise, which is the very worst kind of grass distribution. And so we're going to start with white noise and later probably replace it, again, because I said it's terrible. So if I wanted to do that, I need some way of creating a random distribution of grass on this thing. I'm just going to hack in some of that right now so that we can start testing this stuff out. If I go in here and look at how we're storing this, right, I've got a ground cover thing. We go up and look at the ground cover. It's got, what bitmap did you want on there? What was the location? How big was it? And what color was it, right? And again, I think we're gonna go through a couple iterations of this, so don't fixate on that. This is just one way that we're gonna put that in there, but it's, yeah, things will progress from here because we're gonna want to simplify the amount of work we're doing for some of this stuff. Anyway, so I want to do a couple things. One is I do want this to be timed function because I do want to know if our unpack fills are taking too long. If we start putting more complicated stuff that goes on in here, I want to see that show up on the profile as a separate issue and not bury it in some other buddy's timing. So what I want to do is distribute the ground cover here. I don't know how we want to pick that amount, but for now I'm just going to do the maximum amount. So we're going to actually just fill that to the brim. And we especially, I think, want to do that at first to get, because we're going to want to stress the system, see it be really slow, and then improve it so it's nice and fast and that kind of stuff. So I'm going to go with the maximum count for the ground cover right now and just let that be sort of the high water mark for slowness. And then we'll pull it back. All right. So we've got the cover index here. We're going to loop over those, and we're going to fill each of these as we go. So here's here's where the ground cover goes. This thing is going to need some kind of a random point. It's going to need one of those bitmaps, right? It's going to need a color, and it's going to need a scale. And so at first, we can just keep this pretty simple. This is going to be the thing we're going to have to randomize for the placement, but that shouldn't be too hard. And then the bitmap is a little bit more complicated because we're going to need some sort of a idea about where these bitmaps actually are, right? We're going to have to do something where we pick sort of, ask the asset matcher to find where these grass bitmaps are and figure out which ones we're putting in there and why and that sort of stuff. So we need to do those two, and that'll be most of what we're going to do. However, obviously, when we're filling an unpacked entity, not everybody gets ground cover. Only the actual grass tiles or other tiles that we deem suitable for having crap scattered on them. And remember, we may want this system to do other stuff like scatter rocks around the dungeon, or splotchy little stains, blood stains, who knows how gruesome it can get when Krampus is involved. But point being, we will probably use the ground cover system for more than just grass as well, but either way, the point is not everyone gets it. Only entities that are supposed to have ground cover get them, and that particular ground cover probably wants to come from a set of ground covers and also maybe have some settings on it about what it should actually be. And so in here, I want to store that information. I'm going to say that maybe we've got some information here that tells us about how our ground cover works. So, like, we've got something like the density value, maybe? I don't know. And then we probably have a type of ground cover that needs to be there. Here's what I will say. I don't actually know. I don't actually know how we want to do this exactly. When we look at our... Let me load up our tags files, because I just don't even remember what we've got. I know we've got ground cover in there. We've got some grasses and stuff. I don't remember what we did with it. So here's our tags file. And so somewhere in here, we've got some like grass and crap. Here we go. So we have like grass 1, 2, and 3. We've got some rocks. I'm not sure what puffs are. Let's take a look at these actual files, because, like I said, I don't really remember what we've got here. We've really never looked at these before. So, sources, base game, art. So, it's in the particles section here, firegrass, this stuff. So, it looks like grass... Yeah, I don't know. I think these can just be fairly interchangeable. So, it looks like these are maybe little splotchy things, whereas this looks like thicker cover, maybe. These are flowers. right? So I'm not sure really what we want to do. Let's look at those rocks, though. Okay, so the rocks are kind of like more occasional scattering. So I don't really know how I want to do this, but I'm just gonna go like this for now. So I'm gonna do a cover types thing, and I'm just gonna say, look, we're gonna have a field. And then I'm just gonna assign crap to the field, because I don't know, right? Let me do it this way. And so I'm just going to make a few cover types here that I might want. And so I'm going to say, look, if you want, you know, thick grass, grass splotch, and rocks. I think that's what we've got at the moment. Oh, flowers. I'm just going to say we got a bit field, and that has that in there. And then what I'm going to say is that density value, I guess, tells you what that is, like how dense you want to be. Although now that I think of, well, you know, now that I think about it, that doesn't really work particularly well, does it? Because you probably want to set the density differently for each type of cover that you wanted to splat on there. So thinking about it, you probably want something like this, or like that, and you probably want to say that it's going to be some kind of a packed value that gives you both of those pieces of information like separately, right? So you probably want something like this. Maybe. Does that seem reasonable? And so then you would do something more like grand. So the cover types, again, I shouldn't have deleted those. They're just, you know, they're the same. They're just not going to be bit fields anymore. They're just an int that tells you which one you've got. Something like this. And so you can have 256 different types of ground cover. Well, technically 255. One of them is non-cover. And then you can set a density value, and that density value will mean something, but I don't know what. And so each entity can get that piece of information, right? So the ground cover type here, density might just be how many there are at this point for us as well. So something like that. So anyway, inside the ground cover type thing, we'd pick one of those, and then, you know, over when we're doing this, this can be a loop itself that's sort of like, let me loop over the ground covers that are specified for this particular place, and we'll put them forth, right? And so, like, yeah, you get some number of this. You can splooge on there, and after you do each of those, you're done, right? So, okay. Seems reasonable to me. So what I want to do now is say, all right, in that case, the way that this is going to work is more like this. Loop over each of the cover specs that we have. Like so. So we're going to go through each one of the ground cover specs, and we're going to process them in order. If we hit the end of the amount we can store, which would be this, we want to stop then as well. And then here, actually, I suppose we can just put that one here. So this would be our complete set. Now, we're going to know ahead of time, like we don't really have to do this check in line because we're going to know ahead of time where that would actually be. So for example, what we could do instead is say, all right, let's get that density count out of the spec first, right? Then let's say, all right, how much room would there be if we were to use all of the remaining space in the ground cover array? And we can just clamp that density count down from there, right? So if I did a thing that said, like, in fact, here, I'll do it this way. This would be the easiest way. If I just said, look, the density count is going to be however much room I could afford at the moment, minus how much I have used so far, that's how much we're going to put here. But if the spec density is actually less than that, right? So, meaning if the density count would exceed how many I was asked to plant, then just clamp it. And you may ask, why do that? Well, the reason is because if I clamp the value first, then it doesn't have to check it every time through the array, through the loop. It can just check it once, right? And then we do both of our checks with one if, right? It just simplifies the code for the CPU. So basically, you just pick the minimum of the two here, and then when you do your loop, you're only looping over one, and off we go. So when we do our ground cover, now we're assigning it across multiple specs as well, which is nice. And this doesn't have to be here anymore either, so that can go away. And so I think that's all good. Now, what we want to do is actually pull out that spec. I never actually did that. Also, we now no longer need these two. And so here I want to pull out the spec in question. And now we have, I think, what's completely functional for all our entities. And this loop will never get entered because nobody will have set any ground cover on themselves. So we won't generate any. And that's fine. However, if we actually did want to generate some, we're going to need some additional stuff here to finish, which is this bitmap and the placement. Going to start with white noise. On the placement, which is, again, white noise is just purely, like, is what you might call real entropy. White noise is an unpredictable, completely unpredictable value. Obviously, we can't get completely unpredictable values out of a computer, really. Intel claims that they sort of can on their processor, but I don't know how true that is. Either way, white noise is literally random in the truest sense of the word. It's trying to just be completely unstructured. Grass in the real world is not completely unstructured. You will not have it be as likely for two tufts of grass to appear directly next to each other because they're competing for sunshine and rain. So you will much more likely see grass spaced at sort of regular distances but irregular patterns, which again is a more blue noise-like pattern, which is to say randomness constrained by non-overlapping. That is how organic things tend to grow, again, because they compete for space and resources. So they tend to grow into cellular-like patterns that are distributed. So we would probably want to move to a more blue noise pattern or something like that as we go forward. But for right now, we're just going to use pure entropy. In order to do pure entropy, we need to be able to pick a random point on top of this entity here. And so to do that, we need our random series. So we have our random series, let's see here. So we don't really need to do a 4-wide randomizer just yet. We have one here that does 4 at a time. Obviously, that's going to be a fancier version that would be faster, right? So I don't really know that we need to do that. Although I guess we could. So maybe we'll just use the PCG for now. I don't know. Maybe we should just do 4 at a time. Maybe we should. So I guess what I'll do is we will do a random seed with the random series, and I guess we'll do 4 at a time. I guess. So we'll do a random series, and this will be our cover series here. And what I'm going to do is our cover series I'm going to initialize when we do the random seed. So here. What I'm going to do is I'll use the same stuff we were doing here. So this. But what I'd like to do is I'd like to seed it with the entity ID as like an offset. So each entity will get its own slightly different random series. So if I just do this, right, that produces an offset series that gives me a, sort of randomized version for each of the entities separately. But it also means I'll generate the exact same ground cover for a given entity every time I process that entity, which means that even if you went off screen, the entity got packed, you go back, find the entity again, the grass pattern will still be exactly the same because it will have been generated with the same generator. And that just helps keep the world a little bit more consistent, right? Because unless something has happened to that particular tile, the player wouldn't expect the grass pattern on it to change, because why would it, right? So that kind of helps us keep the things feeling a little bit more solid. And I might suggest, too, in here that we would potentially want something like this. Something like this, where we just say, oh, okay, let's do our random seed here, and then we will just, basically just this. Do this for anyone who wants it. So something like that. And that way this sort of thing just looks more like that. And that way we can also like improve this. This is probably not the best way of doing that. So we could maybe make this better over time, and then anyone who needed to do stuff like that could just get it this way, right? So I don't know, something like this. So once we have one of these, what we're going to need is we've got sort of the ability to do random unilaterals and random bilaterals, and we can get that data out, anytime we want. And so what I want to do here is I would like to, if possible, take the bounding rectangle of the top of my entity and just pick a random point inside that. So the question is, where actually is that, right? And if we look at the entity structure, I believe that what that amounts to is in here we have the position of the entity, right? So we're going to start with entity P. And then we have a collision volume that specifies where, what the bounds are relative to that P. So we know that we would do like, get min corner or something of collision volume, right? Or something like that would get us to like the bottom of it. Or I could do get max corner. So I can do various stuff where I like pick out of the collision volume, but I thought, so we have a way of mapping in, but we don't have a way of mapping out. We went through this exact code before. We should have made a function for it because we're just doing the same darn thing again. Right? So when we do, like, when we get the ground point, right, when we get the actual, yeah. So you can see here we actually, all right. Well, I'm going to go look up that code. And I'm going to see where we're doing that stuff. I just want to see if this can be put into a little, yeah. All right. Well, here's what I'm going to do. Since I believe I wanted this function before, I'm going to write it now so that I can have it. So we have a thing called get barycentric, and what that does is it takes a point and it gives you back the barycentric coordinates for that point relative to the rectangle, right? But I kind of want the opposite here, right? I want the, like, this, where you kind of give it, like, here's the UVW barycentric coordinates, here's the rectangle, give me out what the point would actually be, right? And so when we look at something like this, what we'd be saying is, all right, the result is going to be the linear blend between like the A min X and the A max X along the, you know, T value specified by my UVW. You see where I'm getting that from? So we're just going to say, you give us a number between 0 and 1 on each of X, Y, and Z, and we're going to pick out the point in the rectangle that is that point, right? And that just makes it easy to sort of say stuff like, oh, I want a random point inside this volume. Pick a random number between 0 and 1 on each axis. There you go, right? So I believe that that would be the easiest way to do it. So because then I can just say, well, take the collision volume that you've got, and then, you know, take our random UVW, and we're good to go. Right? So we just pick 3 of those, and then we're done. Now, what you can see here is actually we don't want a random point in the volume. I mean, that might be interesting for other kinds of cover that was like gas or something that was filling up a volume. But we're only trying to fill the top. So we know that actually we only ever want this value to be 1 because the Z value should be the highest it always can be. So we only actually want randomness on these 2, right? Makes sense? And so now we've got our random point distributor. So the final thing we need is an actual bitmap here. And again, that bitmap is going to come from the cover spec. So what we want to do here is figure out, is the spec actually something we want? So if the spec, what's that called? Type. If the spec type is valid, then it's, you know, it's actually something we want. If it's set to 0, then that means this isn't used, this ground cover isn't used, right? So once we test it, what we then want to do is say, we need to sort of have like a bitmap table, or however you want to look at that, for looking up the various ground covers that we have. And there's a few ways we might want to do this. It's kind of one of those places where we've said many times we need to redo how our tag matching works, and that's very, very true. Because I don't think we want to, on every bitmap, actually make the call to do the asset matching, because calling it 64 times is way too many times. So what you really want is just a table that you can look up in and get those variants more quickly, where you just pick a random number in that zone. I'll start with the crappy version, which doesn't do that, and then we'll go from there. So if I look at the code just slightly above this particular code, you can see us doing the bitmap retrieval using the matching vector. So, you know, you can see this here, like this, for example. And so here we don't have really any other information at the moment, except for the fact that we've got a variant here. And the weight vector wants to do that too. And what we're going to do is the match vector's variant part itself will just have to be randomized every time. So each time through here, we would do random unilateral, and we would send the cover series down. When we actually then go into get the best bitmap, this is the code that would have to actually run, right? And so this asset category thing here is this asset basic category, and that's just going to be particle, I believe. And then the rest of this is all good, right? Okay. So because we have to do asset queries in here to assign these bitmaps, that does also mean that when we're in here, we're going to need that asset system. And so that's going to create a little bit of a call chain issue for us. So we're going to have to make sure we pipe that through properly. But otherwise, that's what we would want to do. Now, the rest of this stuff, facing direction is not really what we want to be pulling out there. So what we want to do here is we actually want to do sort of a switch statement on the spec type here, where we actually look at these ground cover types I defined, and we want to say which ones of them, we want to say how they're going to get looked up, right? So we've got rocks, flowers, thick grass, and splotch grass. We can go into the HHT and see what those are set to. And so here, you know, you can see we've got cover set, and then we've got flowers set, and then we've got, I guess, where are the rocks? Stone is set, right? Why the flowers aren't set to cover, I don't know. Because that seems a little bit odd, but, you know, whatevs. So in this kind of crappy system that we've said many times we need to redo and have never redone, we then need to just kind of laboriously fill this garbage out. All right, so we need something like this. And you're going to see how ridiculously crappy this is. I mean, like, this is not going to stay in the game. It's just a terrible idea for so many reasons. But, you know, got to stick with what we have for now. So in here, we got to look at this weight vector here and say, okay, for rocks, what is it that we're going to use? So for here, we want tag rocks. Why is that not a thing? Oh, it was stone. Cover and size. Actually, I don't think we needed size for this one. Right. We don't care about the size because there's only one size of rocks at the moment. For our flowers, looks like it's just that. For here, we've got cover, and oddly enough, there's nothing else on it. Seems bad. Shouldn't it at least be labeled like grass. Am I totally off base here? So splotch grass was the smaller one, and thick grass was the larger one. And off we go. So again, really crappy. And just to be clear, the reason it's crappy is because what you want most out of an asset system is you want it to deliver assets to the game in the way that the game wants to use them. And so, for example, here what we want is we want to just be able to say, give me the rock data set, how many are there, right? And then I'm going to distribute them. So it doesn't want the asset system to match. It wants to do the variation. So it really just wants to be given like an array, like here's what they are, right? And so I think probably even if we just kept the system the way it is now, it's actually fine. We just need to move to a system where you could ask for that and get back the array as something that's a queryable that you just do once, and then you can distribute it from there. So we can do that without too much upset. But as it is now, it's really pretty crappy. All right, so we now have our fill unpacked entity here. I don't know what some of this stuff is doing, or if anyone's even calling any of this stuff. We should just test to see. And we're going to have, again, to route that asset system through because, again, we need that when we're unpacking the entities. So we know that's true. Let's see what else we got. Random seed offset cannot convert everyone from entity ID. So I want to look at what entity ID is. I probably just need to get the value out of it. Yeah, so we'll just do that. Entity undeclared identifier. I agree with that. It was supposed to be called entity, but we didn't call it entity. There we go. Same there. And that was just a typo. So hopefully now we're down mostly just to the routing issue there. So here in fill unpacked entity, we need to find a way to get the game assets through, which means that when we're calling this part of the unpack here, we need to have that, right? Because I don't believe the world knows where the assets come from. You can see here it's unaware of that. So when it calls ensure region is unpacked, somebody at that stage has to be able to provide the assets. And, you know, easier said than done, because I think that's typically not happening in here. So when we call begin world change, and that's when you're doing sort of that unpacking, that's where we would actually need that data to be given. All right. So let's just force it through. And again, I'm just walking up the stack and requiring everyone who was previously making a call down this chain to provide that information, right? So how is this guy? Yeah, so this guy needs the game assets but doesn't have it. And so the world sim struct itself should have that in there, meaning Although I guess the World Sim work structure actually could have it in there. I don't know that World Sim itself needs it. So it's probably more like that, right? If the game state's there, though, game state assets actually has it, right? So I could just do that. Sorry. That. Although now that I look at it, does the game state get passed here? It doesn't. Okay. Because say if simulate has the game state, it could do it, but I guess not. All right. So let's see. Game state assets. Does Gen have the assets? Again, this is just kind of busy work. Oops. So I feel like the world generator should have the assets because it's going to need those for various querying purposes. So we probably need to put that in here. So yeah, so in here where we're like doing begin world change, we want to, oops. And then that just needs to get actually set when we start the world gen. So that's going to be in worldgen.cpp. And when that stuff gets initialized, probably delete a lot of this crap now. Looks like we saved a bunch of room stuff. In fact, I'm just going to get rid of all this. So when we first create the world generator, right here, this code is going to need that. And so where we call create world, we will have to pass the assets as well. And so I think that's everything. It's a little bit long-winded, but we really do need those because when we're randomly distributing detail features, we're going to need to ask the asset system, like, which ones are they, right? So I think that's all good. All right, so I think we're mostly done with that. And now we can distribute points on our stuff whenever we want to. Now, there is one issue that we have not addressed that we do need to address, though. And that is that when we are creating our entities, they will not have been actually updated for like with the ground cover, right? The reason for that is when we initially create our entities, we don't do any of the unpacking stuff, right? We just create the entity and that's it. What that means is that all of the entities that get created that have not been packed will not be unpacked and therefore will never have that called. So actually, what we want to do before after we gen the world, right? So when we do create world call, and we do this crap, right? What we want to do is at the end of it all, so when we do like begin world gen and then we do end world gen, the end world gen stuff, actually this needs to tell the simulation system, like the world system, to flush the entire cache because everything should get brought in afresh, right? So inside that handmade world system here, we need to flush that. Where is that? Okay, so right here. So that unpacked entity count that says how many entities we have stored unpacked, that just needs to get set back to 0, right? So that's what we need to do. How would we do this? Well, there's a couple different ways we can do it. At the moment, we could literally just set it back to 0. But if we start to introduce things that maybe manage other resources as a result of entities coming in and out of the active set, we want that to sort of happen generally in one place so we don't screw it up, right? And so in order to do that, what I want to do here is make sure that... let me just add the call here before I forget. So inside end world gen, I'm going to be clear unpacked entity cache in gen world. And so then here in the world calls, I want an ability to do this, where I can just say right. And like I said, that's not really what I want, so I would like a way of unwinding everything there. And so in order to do that, just to keep it clean, so in here where we do this operation, and we take the entity position and we remap it and pack it and all that sort of stuff. I guess I don't actually know why the chunk... Oh, okay, there we go. I was like looking for something and I wasn't seeing it. So this entity P here, where we do the map into chunk space, I guess I'll be honest, I'm not sure why is that happening outside here still. So if you look at that, I was expecting it to be inside and it wasn't. If you look at that entity P, you can see it's only really used... there it is. Okay, because it's used in here. I was like, why is that outside? So if you look at what's happening here, what I want to do is effectively have a way of making sure that this stuff happens consistently in both cases. And so what I'm thinking of here, this is just kind of my loose kind of opinion of what I kind of think I want to have happen, is when we do the de-unpack origin here, I think I want to pull this out into its own sort of separate pass. So this I think I just want this to be a separate function that gets called here by default. Something like this, so that we always go through kind of like a known case, if this makes sense. But then have two ways of running it, one way that clears the cache and one way that actually makes the decision. Something like this. Now I guess the other thing, maybe it's better to, now that I'm looking at it too though, because that's sort of, it also calls register in there. Maybe we don't really quite want that. You know, maybe we want something more... Maybe we want something more like only taking the interior part. So like literally just this. Maybe. So if we did something like this, where you would say pack entity, and it just packs that entity into some place that it's going to go. Yeah. Maybe that's better. So we call pack entity here, and then we'll have a loop here that calls pack entity. So this would sort of take us through the entire set. You know what? Why would I do that? That's just unnecessary. Let's write it clearer. So I'm just going to loop through. I'm going to say for each one of these entities, I want you to pack it back up. And then I'm going to say that we've got none. Right? Okay, so now the only question is, what does pack entity actually need to do its job? So it needs a couple things. First of all, it's going to need the world, right? Because it's going to pack that up in there. It's going to need the packed entity size, but the packed entity size is something we can know offhand, and that's fine. And eventually it'll go away because the entity size will vary, right? So we're going to need that. We're going to need the chunk delta, and that will be 0. I'm sorry, not the chunk delta. The entity p. So when we actually map it into chunk space, we're going to need this value, right? There you go. I think that's everything. Looks good. Okay. And so in here, where we do pack entity, it needs to simulate those. So it needs to be able to do that pack. And the way it's going to do that is just using the unpack origin that was used last time, because it knows that there have been no updates yet, right? So it's literally, it's the same call, right? It's just that. But we're just doing it outside because it was needed here for other reasons. Right? So I think that's all we actually need to do. And that allows us to do a clear of the cache that packs everything, right? Of course, it would also help if I packed past the actual entity that you're supposed to be packing. All right, so here we've got the entity P and the entity itself that we're working with. Those are both known. Here we need that entity again. Other than that, I think we're all good. So I think this will properly clear the cache. And it calls the same code in both cases so that as we change that code to do that packing in other ways, hopefully that will work, right? Didn't like that. Hold on a second. I may have forgotten to wait. World gen. Seems like that should be okay, shouldn't it? Well, we'll see. So I'm going to go ahead and compile in debug mode. We're going to debug this, and then I think we're probably getting towards the end of the end of our time today. But we've got the ground cover distributing, and hopefully all that stuff is functional now. And so if we drew it, we would presumably actually see some stuff. All right, so on our call of clear unpacked entity cache, it looks like the world structure is set to 0 for some reason. So I guess well, I'll be honest, I'm not really sure why that's the case. Right. Because we cleared our memory. There we go. So I think we can test this now and see. Of course, we're not really going to know whether or not this is working because we're not drawing the ground cover, but I think we've got everything in place for the ground cover to work just fine now, albeit perhaps a little bit slowly. I want to take a look at that profile real quick, and then we're going to hop over and actually put some drawing code in there so we can see about the ground cover. We've got to actually ask it to generate some ground cover, and then we have to actually draw it in order to see if it worked. So in here, we can see our memory usage. If I look at the arenas, it looks roughly the same as it did before, which is more or less what we would expect. If I go over to the profile, I just want to make sure there's no weirdness going on there as we're moving around. Light propagation, as you can see, still taking pretty much all the time. Nothing unusual there. It's exactly what you would expect. Yeah, I mean, really, this is just exactly what we would expect. There's nothing interesting here. It's just lighting calcs eating up all the time. And that's what I wanted. That's what I wanted to make sure. All right. So if we now go and actually set some ground cover on our grass entities. So for example, inside room gen, oops. Let's go look at where we're getting some grass selected here. And so when we do this add tag grass, what I'm going to do is say, when we add tag grass, I'm also just going to go ahead and hard code some ground cover in here. And then later we can make a system that thinks a little bit harder about it. But for now, we'll just say, if we were going to set the thing to a grass type, I'm going to set one of these ground covers here with the type and the density. So what I'll say is, well, all right, we'll take those ground cover specs, 0, and we'll do like a density of 16 or something, and the type will be thick grass, right? So now we're like asking for ground cover to actually occur, and so now we might see it show up on the profile, but probably not, because it's probably not really doing very much. But we should actually be getting calls to it now, right? And looking at like there's nothing happening here in particular, as far as I can tell. Sir, I don't even see it on here. It's called fill, right? Fill entity, but it's not even on there. I mean, it should be in there somewhere, but I guess it doesn't get called except when you unpack, and you only unpack it, so it probably just bloops on and then bloops off, right? So now that we've got it, asking to do that cover, what we need to do is actually try to draw that cover somewhere. And so if we go into the entity system and we look down where it's actually doing that drawing, you can see here, like, for example, this is the part where it loops over the pieces of the entity and draws those. Let's try to do, that same sort of thing. Let's try to do that for the ground cover here. So yeah. Maybe I'll make a little section for that. And we can isolate this out, maybe. So the p-values, now that I think about it, those actually want to be offset by where the entity is, right? So if we take a look at how the entity fill is happening, I actually don't want this, right? Because as the entity moves around, the ground cover should move with it. So on here, like, you imagine like a floating platform that was like moving around or whatever, you want the grass to go with it. You don't want to have to go update all the grass every time. And so I guess what we want to do here is say, okay, like, let's go ahead and say, draw this thing like that. And let's make a little function here that draws that ground cover, and we'll see what that looks like. So here's my draw ground cover. So what would I actually need for that particular part of things? Well, in here, if we're doing like a push sprite call, which I assume is roughly what we would want to do, so we need to be able to do the load bitmap in the case where it fails. But other than that, I don't think there's particularly much there. So we don't need any of this. Oops. So we're really just looking at this. So we need the render group. We would need the game assets. And that's about it. And so the rest of the stuff we can actually just get out of what we have right now. So I think that's where we're at. We would want to do this sort of thing. And popping over here, it occurs to me that we never really stored into the entity how many pieces of ground cover there actually were. And so we probably want to do that, although I suppose we can just bail when we see a bitmap ID of 0, and that would be sufficient also. But I don't see any reason not to just go like that. So I think I may in here instead say, do this, right? All right, so I'm going to do it this way. I'm going to loop over these in order. For each of them, I'm going to get out the bitmap like this. I'm going to load it if we can't get it. I don't know that this is a particularly good way to do this part of the code, but, you know, as we streamline the rendering of the entities, I'm sure we can take care of most of that. But then we really just need to know what the actual layout of this sprite is. And we can probably use our existing code for that, although for ground cover, because there's so much of it and because it's very specialized, I could see us wanting a particular piece of code that operates just for ground cover to figure out kind of how it's arranged and where it goes. So if we take a look at updated and render entities here, when we actually create that sprite bit here, again, not really sure exactly what I want this to look like, but we'll figure it out. So if we look at the X and Y axes, those are going to presumably just be the same as what you would expect. So we're not really going to be modifying those. Again, this is why I say this should probably be welded into something that doesn't take into account any kind of morphing of those or deformation, because it can be much faster, right? For the align P, again, don't really know what I want there, but I'm guessing... Actually, I guess I'll just do it this way. I'm guessing I want something sort of like this. We can look at that a little bit later. And then for the world dim, that's how big I want the thing to be in the world. And that part is a little confusing because, again, we need the texture information for that. And so I don't know how the world dim actually bakes down, like in terms, in terms of how we want. So you can see us using the bitmap info for the thing here to actually do getting the actual dimension of it that way. Again, just a lot too much going on here. What we probably want to do is actually bake this down into the ground cover. That's what I'm guessing, because it's just way too much fussing. Just way too much fussing. So if I want to get the actual bitmap info there for that particular bitmap, that's actually not very hard though. We can do that pretty easily. So we just say, okay, give me that. And in here I can just say, all right, whatever this thing wants to be. I don't know what the height ratio. Yeah, that's a thing for sort of chaining stuff together. In terms of how big we want this, I think that's going to come from the cover scale value. So that's how big you want this thing to be. So I think that's fine. All of this should cascade together now, and we should be able to draw... Oh, and this actually comes from the cover as well, right? So I think that's roughly right, but again, there's too much work going on there, and so I think what we want to do is, over time, migrate that into something that just builds the correct render set, and then we just offset that and move it to where it needs to go, but other than that, we don't touch it, right? Okay, so this is actually not bitmap ID, it's just bitmap. It's just that. And then draw ground cover needs the asset and the render group. Assets, render group, entity. We do get past the assets here as assets, yes? Yes. Okay. That should do it. There's one error there we got to look at up at the top. Push sprite is unhappy. What is it? From bitmap ID to... Oh, render texture. So this just wants the texture handle at that point. And it also looks like it wants... it looks like it wants those axes in world space. So these are actually V3s, not V2s. Oh, no. Maybe not. Which one was it complaining about? Oh, is it actually the fact that it wants a V4 for color? That's probably what it is. So we actually want the V4 here just because we can specify an alpha value. That makes sense. So I think that actually would attempt to draw the ground cover now. And so now we have to debug the system and find out, okay, first of all, is our... Well, we're not seeing it, so no. But first of all, we have to make sure the ground cover is actually getting generated. And then we have to, once it is generated, make sure that it's actually getting drawn. So we've got 10 minutes left. Let's see how far we can get in that. And what we don't finish, we can do tomorrow. So first things first, let's make sure that we're actually ever getting any ground cover generated in the first place, because we may just never actually have any ground cover set, in which case we're never hitting the rendering code. So that's the first thing I want to verify we're actually doing. So I'm going to set a breakpoint in fill unpacked entity, just so we can do a spot check on that. And so here where we're actually creating one of these things, I just want to see that it's actually, you know, ever happening, right? So you can see us switching on the ground spec type here. Do we ever get in here? We do. So somebody is correctly setting the ground cover specs for at least some entity in our game. And it looks like thick grass is... Oh. Already thought of one thing I forgot. I said I wanted to start storing the count. We never stored the count. So infill unpacked entity, what we want to do here, excuse me, is instead of actually using this cover index, we actually want to use the entity ground cover count. I can actually just use cover index though if I want to on the outside. So when we actually start this right here, I can just say, okay, the entity ground cover count equals the cover index, and then we're done, right? So that needed to happen. Let's run again and just make sure we know what we're seeing now, because we may see something different, and then we'll change our strategy for how we're debugging. All right. So I'm still not seeing any. I feel like there should be some ground cover over here, right? And I'm still not seeing anything in particular, or at least if I am, it's microscopic, so there's nothing there. So let's go ahead and again take a look. I'm going to set a breakpoint there. When we come through here, I'm going to see what we're actually generating in terms of ground cover, just to give myself a sense of whether the values make any sense whatsoever. So I guess I would say the collision volume maybe isn't set properly. These are all zeros, which is not good, right? Yeah, and so you can see the collision volume here for this entity that has ground cover on it. It's actually set to not be anything. I thought we were setting collision volumes on all of our grass stuff, though, so I don't really understand why that would be happening. I thought, like, for example, when we actually set these, they had collision volumes, and that's what we were also using. We were drawing them, too. In fact, let me just... Okay. I didn't mean to do that. I just, like, ran the game in a separate way or something there. All right. So that's pretty odd, and I guess I'm going to go take a look at that, because I want to make sure that that makes sense to me first, because I don't really know what's going on there. So let's take a look at when those collision volumes actually get set. I'm guessing that they don't actually get set inside here. They get set presumably when you actually create one of the entities. So here we're adding an entity. Yeah, so I don't know. Collision volume isn't ever getting set there. But didn't we use this specifically because it... Oh, interesting. So we don't create collision volumes for our non-apron entities? So that's an issue, because I really... I think we want those, right? I mean, we want those collision volumes to be there. And they don't have to get used for collision, but we need these volumes for a lot of stuff, such as distributing grass on the entity. There's a whole bunch of things we need it for, right? So when we do this collision volume here, I think we want to do that in both places. When we do regular entities as well, so this part here where we're actually creating this thing, and we're adding the piece onto it, like this right here, I think we want to create the collision volume for the entity in exactly the same way. So we want to do a... We want to do a get volume from min z kind of a situation here. We've got the wall height, and we just need that entity relative bit. So I think we want to just do the same thing. Now the tile, in this case, we should have that tile in both cases, and we do. So I think we should be able to do that, and it should be okay, right? We'll have to debug that and possibly visualize it, but I do think that's what we want. And then when we come through here, in theory, this collision volume should not be garbage anymore. Yeah, so that's more what we want, and that's good. So now we should see these values being more valid at the end of this, so I don't have to stress about it, right? So let's take a look at what the cover value is now. Okay, so that's much better, right? That all looks good. Looks good. Okay. So that's one good thing. The other thing we're kind of going to need here as well, and I guess I didn't think about this when we were doing it when we first typed it in. Inside draw ground cover, I don't think I ever actually moved this thing based on where it was originally. So for example, when we're doing this push sprite call, and we have the sprite min-p here, when this is actually getting created, when are we ever offsetting it by the entity's position itself, right? Because I don't see that happening in here anywhere. And, you know, this ain't going to do it. So I feel like the min-p was probably getting offset in the other code in a different way, and we didn't do that here. So we need to, that's the other thing that would be why we wouldn't be placing the grass in the right place potentially. So when we come through here and we look at what it's doing, like, yeah, you can see here, right, we're offsetting it by a bunch of information. So I feel like that probably needs to happen as well. So what we want to do, I think, is in here where we do a push sprite of the min-p, what I want to do is take the entity's position and offset it by that, right? Because that's not getting counted for. All right, getting closer, but probably still not quite right. So let's see where we're at. Here's this is the debug build, so it's excruciatingly slow. What I'm going to do now is I'm going to break inside that entity render call and just see if we're ever getting there. So it's just the draw ground cover part. And that will hopefully give me a little bit more of clues as to what's going on here. So some entities will have no ground cover and some will have ground cover. So, well, turns out the first one had it, so that's good. Because I was going to say we got to break inside one that actually has some ground cover. If we look at what its ground cover count is, 16, that seems fine. Let's start to take a look at what we actually pushed down for sprites. So the texture handle was valid that we got, and the cover that we have here seems pretty reasonable, right? The only thing I would say is the Z being negative, that seems wrong, and I can't really think of why the Z would be negative. If it was... I would not think the Z should ever be negative, so that just seems bad. But regardless, let's just look at what we were going to say here. So if this entity placement, whatever it is, there's the Z value. What's its collision volume here? So its maximum is actually below the Z of the thing. So I guess that's technically correct. Maybe we're setting the collision volume wrong. So we'll have to go debug the collision volume as well. That's the other thing we'll do. But otherwise, let me look at the sprite values to see what those are. So all of this looks pretty reasonable, right? So I don't think we're far from working. Like, I don't think we're in like a ridiculous territory. But we're definitely not quite there yet, right? Not quite out of the woods yet. The other thing I would say is we're not generating grass on the apron, now that I think about it. So the actual grass is not going to be there. Let me go get us over to an area. Well, or I can just tell the... You know what? Let's just tell the apron to do it. So when we actually create the apron, which is not actual places that the player can go, it's just there for visual effect, let me go ahead and slap a ground cover on the apron, so that way we can see it right when we start up. So here, when we create this stuff and we add the tags, I'm going to set it here so that it gets the same thick grass ground cover, because why not? And now when we run, we should see if there's any ground cover happening on those apron entities or not, right? And so you can see some, but they're obviously kind of weird and wrong, right? But we're getting there, so that's good. So let's try and figure out what's happening with that code. I'm gonna look at just a few really quick things, and then we'll go to the Q&A. So all I want to look at now is when we do unpack, I should say fill unpacked entity. I want to make sure that this part of the process is working okay. So where we do the random UVW and we get the point here for the cover P and that we unpack it right, I want to make sure that there's nothing particularly bizarre going on in there. Okay, so you can see, so I forgot when I wrote this code, I didn't use the cover P at all, right? So that's just totally garbage too. So this is actually that, right? So that was probably a big part of that problem as well. Okay. So I'm going to probably call it there, and we'll do more debugging of this tomorrow. But I think we're basically where we want to be. We've done the systemic work. There's just some tuning, but I think we're good. So if you look there, you can see that we've now got like rudimentary ground cover sort of working. I think the Z is wrong on these, so I think the collision volume is actually in the wrong place. So we need to debug that tomorrow. But you can see the ground cover is working okay now, right? And honestly, that's pretty much it. So we're almost there. The ground cover it's too big at the moment. You know, it should be more like that. But other than that, I think we're okay. The other thing I want to take a quick look at is, can I just fix that Z value? And then at that point, we're pretty much going into tomorrow with mostly done. And so then we can maybe start looking at lighting and getting the ground cover lit and all that stuff. All I wanted to look at here was inside the room gen, right? When we're actually, this one, we know that these have correct collision volumes, I believe. Although I don't know if we Minkowski sum them. I don't think we do. Right, yeah. So when we're actually creating the collision volumes in here, I'm putting it sort of in the wrong place. I just kind of slapped it in there. The question is, what was wrong with what I did? Why is my Z getting kind of off? I want to look at how the piece is getting added at the inside this one here. How are we adding the display piece there? You can see it's calling get radius and get center on this thing called vol, which is actually the collision volume of the unit. What I'm assuming is this right here. Yeah, I'm assuming that this is just garbage. We should be really doing this add piece call the same way we're doing it here, I think. So I think what we want to do there is when we get that wall height, right, we just want to do this. So I'm going to say, yeah, the vol is going to be the wall height, and it's going to be relative to that p-value. We're going to come in here and use the same stuff we were using for the piece and get that ready. The 0707 part, again, should be baked into the tile's automatic creation of that stuff. So then I'm going to call get center here, like so. And I think that's now, those are in line more. So when we call this vol call, then the place where we set the collision volume to that should now be able to just use that value directly. Now, again, I don't really know why we were getting the wrong Z there, because I think that should be basically doing the same thing. But let's just see what happens here. I want to see where we're at. Okay. I see what's going on. So basically that... it's because the volume wasn't offset by whatever the stagger was. All right, so let's just fix that, and then I think we're done for the day. Good. I'm glad we looked up what that was. That was going to bug me if we didn't. So if you look here, what happens in terms of the staggering. So I guess I'm not sure why that would have flattened everything out, though. What am I missing there? Because that p-value, there's the randomization sort of the up and down float of that entity. Oh, okay. Yeah, I see. So when we're doing this make relative to, and we're saying we want this volume to be relative to it, this is not offset yet. So it hasn't been sort of, you know, sort of jiggered for any kind of displacement that you might want it to have, like an uneven displacement, right? So really, I guess you want to do this, which is a little wonky. And again, we probably want to streamline these more. Now that we have good utility functions, we probably want to make those a little bit more clean, so that it's not so weird and hard to parse there, right? Oh, that was weird. So when we actually take the wall height and we get the P here, then we just need to do our displacement, right? That's all. We don't need to take the wall height into account at all. And then when we displace the entity, the collision volume will just go with it, right? So I think that should be fine. The only question is, yeah, where do we place the part you're actually standing on? But I think that should be fine. So then when we place the actual part you're standing on, which would be here, this needs to get sort of put at the top. So it sort of needs to, yeah, it needs to take into account what the actual collision volumes min z is for the area. So because the ground P is up on top of it, right? So in this case, yeah, the ground P would be what? I guess it's just in the center, which that would be. And then it's actually, well, it's just the max of the volume, right? So whatever the offset is for the entity's actual top part, that's what it's going to be. Again, I don't like having to do all this math in here. We really want this to be something you can ask about entities, and I think we should kind of, maybe tomorrow that's actually what we'll do, is clean that up so that we're not constantly talking about all these little pieces like this. But yeah, the volume actually has a, right, get dimensions, I believe. And so you just want to go up to the top z-wise, and that's where you'd place the actual traversal point that entities are standing on. I think, right? Well, it doesn't look like that actually worked, right? Because that's what, when I actually place where that ground P is going to be. Although we're not actually using it. So when were we actually planning on specifying that, though? Like, when are we adding that traversable? It's the traversable that I wanted to change. When's that getting added? I don't know. Oh, there it is. Okay. Yeah, I'm losing my mind. So this is actually the part that I meant to change, right? So this actually needs to be offset up from the ground, that traversable, by whatever the amount is here that you're actually using. So when it creates this information, it needs to know this ahead of time, right? Because that traversable is always going to be however far up the volume actually is. And so, yeah, when we come in here, we've got to do like, okay, what's the wall height? I don't actually know where the wall height gets set differently. Okay, it gets set differently in here, right? So when we set the wall height, then we'd have to do this, and then we'd have to do this, right? So assuming that we want a traversable on this particular thing, we need to place the point such that it exists at the top of the volume. We know what that actually is because we have the volume here, right? And off we go. I think this could also be called get min z center p. Yeah. So we can also just, sorry, max z center p. So I think we can also just ask for that position that's at the top of that volume. And again, this is all relative to the entity, so that should work. All right. So I think that's all fine. The only thing I don't know now is to what extent does that still line up with room boundaries? Let's double check that nothing particularly odd has happened here. Still looks fine. So I think all that is pretty good. Looking at the size of those, I'm just going to adjust that now, and then we will call it a day. So on my fill, I'm going to say that those should be about 0.5. I'm also going to say that maybe there should be more of them. And then we're going to say that that is that, and go to the Q and A. Don't really know what we want to do with some of these ground covery things in the future, but we'll find out later. Yeah, so you can kind of see that we need to start lighting them because they're drastically different colors than the things that they're underneath. But that was, you know, we were going to be lighting sprites soon anyway, so that's not really a big deal. And we'll get to that when we get to that. We otherwise are in pretty good shape here. I think these want to be maybe a little lower than that. They go up quite high on the hero. You can kind of see, although I guess they don't really. When the heroes, well, no, I guess they kind of do. So they are quite high. So I guess maybe I was being a little overzealous there. Of course, I'm just not sure how it may be that the art assets need to be drawn slightly differently to sort of how we're doing these here, but I'm not really sure how they should be set up to be roughly the right size relative to the hero and all that stuff. So that might be more the correct size. Yeah. And then we just have more of them. And also, even at this number, if they were distributed more properly, I think you would be fine with that too. Right. Let's get the maximum number in there, just to stress the system as much as possible. All right, let us go to some Q&A. Oops, that's not Q&A. There we go. So I think, yeah, I think we're in good shape here. But you can also see the slowdown from it. So I think, like, again, that's the same. We kind of want to motivate. Let's see if we can get our thread display here. You can see frame display. I don't know to what extent we're probably stressing out the render too much. We also need to generate mip maps and stuff. Like, there's so much we could do to take heat off the graphics card that we're not doing. We're really abusing it right now. And so, you know, kind of going through that lighting pass and making everything look nicer. I think that's a good, like, good kind of general goal. Now that we've got, you can also see that they're too sparkly, right? And that's again because we need them to be mip mapped, and we don't mip map anything yet. And so it's pulling from a drastically large amount of texture memory for no reason right now too. But we're getting there. I'm pretty pleased. Do you intend cover to be used for things like footprints, and do you want cover to be interacted with, like grass shifting as you walk through it, to show a path where someone has walked? So I guess I hadn't really thought too much about whether I wanted that or not, but one of the nice things about kind of doing it the way we're doing it, I suppose, is that that's pretty easy to do. So, like, for example, if you did have some parameter in there that you wanted to modify, now that becomes relatively easy to do. So, for example, suppose you took the ground spec, like if you want to do something like that. Suppose you took the ground cover spec and we made it a little bit larger. So we said, in addition to the 16 bits of data that's going to say the type and the density, like maybe there's some other parameters that kind of come in here that can be set by the game as people do stuff. Like who knows what. And so there's going to be two more in here that are like reserved A and reserved B for now, because I have no idea what, right? But we could totally, for each one of those, set those as the ground cover happens and then rebuild the ground cover. So for example, you could say that every time an entity lands on a section, so like, I don't know where the best place to do this would be, but like inside the code where we actually track when you land down, so when an entity is like hopping along and it lands, just trying to think about exactly what needs to happen here. Where do we actually do the transitioning to planted? That's what I was wondering. Oop, that's not. So right here where we do this, you know, you could do, oh, there it is. That's spawning the little fire. So where we do that, we could at this point say, okay, so whoever like is, whoever you're actually standing on, we want to tamp that grass down or something, right? So like something like this, you know what I'm saying? And so when we call stomp on entity, we'd probably say something like, well, who is the actual entity that we're now kind of stepping on, right? And I guess that's the entity occupying there. Let me make sure I have that right. It's been a long time since we did anything with this. But the actual like thing you're standing on is, it's I think called occupying, right? And it's a traversable reference. And so it's got an entity ID in it, right? So I think what we could do is say, all right, take this this entity here and like update it. This actually spawn fire could happen there as well, but I guess we'll say this person stomped on that person, right? Something like that. You know what I'm saying? And then what we do is we say that call, stomp on entity. And I'm not sure really what to name these here, but I guess we would call them the like stomper and the stomp E. You know, we could say, all right, so who's ever doing the stomping, they're gonna like spew out some crap, right? But then we also want to take the stomp E, and I guess in this case, this is actually an entity ID. Look them up and see, you know, who is that actually. So the stompy equals get entity by ID of the stompy. And if that's actually a person, maybe we want to go in there and muck with it. So then we say like, okay, yeah, the stompy's like ground cover. In fact, I guess you could even make footprints be one of the ground cover. I wasn't going to do that, but I guess you could do that. What I was going to say is, let's just change like the color value here. So, you know, we would set, maybe we just say like, okay, the ground cover that actually was requested in here. So the ground cover specs. I'm just going to reach in, I'm randomly doing nonsense here, right? I'm going to say that the reserved A value is now set to 1 instead of 0 like it was before or something, right? And then I'm going to say to like update that entity. So, you know, this call here, I'm going to call that again. Right? So, you know, that gives us some way of doing something, right? We now are tracking where you've stomped around. And so maybe we just want to do, I don't know what, or well, actually, heck, sure, forget the reserved part. For now, let's do something even stupider. Let's just plant 8 flowers everywhere you hop. Right? Make sense? Now in these, you probably can't really see them because they're probably too tiny. Although it doesn't look like they're actually happening. Are we not properly... Oh, because we don't have enough space in the ground cover. We're out of space there. We need more space in our entity for the ground cover. Lucky for me, entity max ground cover is actually kind of cheap to expand because, again, it's only in the local cache. Lucky me. It's almost like I planned for this. So I think you can just kind of go through and do that, and off you go, right? And so you can do whatever. Probably with a system like this, you got a lot of flexibility. You know what I'm saying to you? Now, I don't actually want the hero to be dropping flowers everywhere they go, particularly much. That doesn't thrill me. But, you know, let's say you were trying to implement the, like, forest spirit from Spirited Away, you know, well, now you've got it. I can even create it in my dungeon. Oh, right, those guys will do it too. So it's just kind of like a flower festival here, right? Um, you know, which depending on how much you like those little flowers, you may or may not care for. Will there be a sort of transition from the doors to the outside? I suspect yes, but curious of how. I don't think I know what you mean. Transition from the doors to the outside. Gotta fix. I have to stop taking that alpha. We gotta put it to do in there. I should just add it to our list. Can I add it to our list here? Ugh. No, because we got logged out. Thank you so much. Oh, will there be a transition of the grass? So what I would probably say is we will do a little bit, but not much. So probably all we'll really do is right in this region, we'll have like less density of grass, and then we'll have more density further up, right? But that's like we aren't even lighting our grass yet, so we're kind of not at the point where we're ready to be thinking about that sort of thing, obviously, right? That's like a graphical update. If you step on a tile more than once for the flower stack, only if we want them to. So right now they don't, right? They would just kind of, you get one splat of tiles and then they're done. If you wanted them to stack, then what you want to do is increase the density each time. So basically on here, what you'd want to do is say this is plus equals 8 so that they stack. But then remember, you don't want to go too high because eventually you'll overflow and wrap to 0. I'll let it wrap to 0 now so you can see what I mean. But you would normally want to threshold that value at some maximum and then don't go above that. But if you don't do that, then what you can see is you just keep adding flowers and flowers and flowers and flowers and flowers and flowers and flowers until finally you wrapped the 8-bit counter, and then you would get none. So I should, in theory, if I just keep hopping long enough, I should be able to wrap that value around, and then it'll go back to 0. But it's just going to take me a little while to do it. There it is. See it? So normally you would just threshold the value at the maximum number of flowers you wanted to put there, right? Whatever that number is. But All right. Tired. These guys have been this entire time making flowers, haven't they? Oh, I guess not, because they wouldn't start until we got here. But they're just like little flower dropping machines, right? All right. Looks like no questions, so I think we're done. I'm going to pull that out because I don't actually want that right now. But yeah, that's how you would do it. We probably will do something like that, but not at the moment, right? And not exactly that. All right. Thank you, everyone, for joining me for the episode of Handmade Hero. It's been a pleasure coding with you, as always. If you would like to follow along with the series, you can always pre-order the game at handmadehero.org, and it comes with the source code so you can follow along with it at home. I will be back here tomorrow, at which point I'm not sure exactly what we'll do. There's a lot of things we could be doing right now, and so we probably want to do some of those things. Working with the ground cover a little bit more is probably a good idea. However, moving on to the lighting is definitely something I want to do because I'd like to get that sorted and finished. Ground cover and lighting were two of the big things that we just had left to do that just weren't done in the engine. And so with that, I think that's probably it for our cosmetics, right? I mean, it's looking pretty good. I don't know. Yeah, I don't know that we have really anything else we need to do in engine land. So I think at that point we're just on gameplay. I'll try to think if there's anything else I want to do, but we're looking pretty good. I like the look of it now. Feels nice to hop around. It's a pretty looking world. So I think we're in pretty good shape in terms of being like a nice visual, right? So I think like just getting the lighting tightened up and obviously improving also to a certain extent the ground cover, because we only just kind of hacked in the first thing. We probably want good, better distribution there and other stuff like that. Get the MIP maps working, some of that stuff. So we'll push forward on that. Until then, have fun programming, and I'll see everyone on the internet. Take it easy, everybody.